So we are solving problem number 15 in chapter 8 in your textbook. Let me show the problem. At this position you can pause the video and read the question. We have a spring and we have a mass m attached to the end of this spring. Let me explain the problem in here. Initially, this position shows there is no any stretching or compression in the spring, so we call this as the equilibrium position. And then the mass is pulled to a position x is equal to 5 centimeters by stretching the spring, and from this position it is released, and of course because of the forces on the spring the mass will move towards the equilibrium position and it will pass from the equilibrium with some velocity v. And the problem is to find in part A what this velocity is, or speed. The first part says we have no frictional forces involved in the problem, so the coefficient of friction is equal to 0. If there are no frictional forces, the solution is by the change in the total mechanical energy is equal to 0. So this means the final mechanical energy minus the initial mechanical energy is equal to 0. At the final position of the mass here, since there is no any stretching or compression in the spring, because we are at momentarily in the equilibrium position, the only energy that the block has is the kinetic energy because of the motion. So we have 1/2 mv squared minus the initial configuration is this one. We have stretching in the spring and there is no any velocity, but the some energy is stored in the stretching of the spring. So we have the potential energy stored in the spring, 1/2 k x squared, and this is going to be equal to 0. If you solve for v is equal to k divided by m in square root times x. K is given as 500 newtons per meter, m is 2, and x is 5 centimeters. We have to convert this to meters, 0.05, and when you do this calculation you will find the speed 0.79 meter per second. So this result is when there is no any friction involved in the problem. Part B of the problem says if there is a frictional force between the surface and the block with this coefficient of friction 0.35, then what will be the velocity when it crosses from the equilibrium position here. So again we have some energy relation, the total change in the mechanical energy. This time, since we have frictional forces involved, this change in the total energy will be equal to the work done by the frictional forces. And in here this again will be minus, because the direction of the motion of the object is opposite to the direction of the frictional force. So we take minus Fk times distance x, and on the left hand side we still have the same expression, 1/2 mv squared minus 1/2 kx squared. On the right, what is the frictional force? It is the coefficient of friction times the weight of the block times x. So if you solve now for v, this time we will have v is equal to 2 times 1/2 kx squared minus mu k mg x divided by m, and everything is in square root. If you put the values and do the calculation, you will find a less speed this time, 0.53 meter per second. So our velocity will be less than this value because some of the energy is consumed by the frictional force into thermal energy. So this completes the solution.